Welcome back. This is the last lesson about sort algorithms, and in this lesson I'm just going to review the sort algorithms we've learned and talk about their features, their advantages and their disadvantages. So in this lesson we'll look at the bubble sort, the insertion sort, the merge sort and quicksort, and in each case we'll think about the key features and the advantages and disadvantages. If you're following this presentation because you're studying for an A-level, there are a range of possible questions that you might anticipate about the sort algorithms. At the simplest, you need to know the names of the sort algorithms and a little bit about how they work. You should be able to identify the algorithms, the code. If they show you code, you should know which of the sort algorithms it is, or they sometimes show you code with gaps in it and ask you to fill in the gaps. More rarely they might actually ask you to write the sort algorithm. I would say that's less likely. They might ask you to demonstrate how the sort algorithm would work with a particular list. So for example, the merge sort, showing it splitting the list into small lists and then merging them all back together again. And finally, they might ask you to discuss the algorithms in terms of their advantages and limitations. They might ask you to choose or justify a particular sort algorithm for a scenario that they will set out in a question. One other issue that you need to be aware of that could come up in the exam and is important in any case is that we can have sort functions or we could have sort procedures. Sort functions take a copy of the list and sort that copy and then return a new list, which you can save using the old name or using a new name. But the key fact is a function makes a new list from a copy of the old list. And if we're passing parameters, that would be an example of passing by value. Now a sort procedure would work by sorting the original list. It doesn't return a value. And if we were working with a programming language that uses passing by reference, this would be passing by reference. Python will, because we've done a lot of work in Python, will use either of those depending on whether we return or not. So it's complicated, and I think the key fact that you have to bear in mind is my function creating a new list or not? So that's something to look out for. So I'm going to go through the four sorts very, very briefly now. The bubble sort, well, how does it work? We have a for loop to traverse the list, and at each position I, we swap the value at position I with the value at position I plus 1 if they're the wrong way round. So if they're not in sorted order, we swap them until we've got to the end of the list. Then we go back to the start of the list and traverse it again and traverse it again and keep on traversing the list until there are no more swaps to be done. What would we see therefore? Well, we'd see this for loop, this traversal of the list, being repeated inside a while loop, so that the loop itself is being looped. So it's loops inside loops. You may well see a Boolean variable that stores whether or not there has been a swap, and the program, the while loop, will stop when there are no more swaps to be done. So those are some features that you would see in the bubble sort, whatever programming language it's written in. And if we had to evaluate the bubble sort, the key single fact to remember about the bubble sort is it is extremely slow. The speed, in fact, is polynomial, and that means that if n is the number of items in the list, the number of operations is up to n squared. So you can imagine if n is a large number, n squared is a very large number. Therefore, we would only ever really use the bubble sort with a very short list. We can optimize it, and I did explain how to do that in an earlier presentation. So if you can remember, go back and check that out. So that's so much for the bubble sort, basically. The next sort is the insertion sort. And what we will see is a marker passing down the list, so similar to a traversal, but within that traversal we'll have a second loop that's moving items backwards up the list into their correct position. So that is what the insertion sort looks like. What will we see? Well, we'll see a for loop going down the list, and then inside it a backwards for loop, passing values backwards up the list. Sometimes that second list is a while loop, but basically it's going backwards up the list. So the insertion sort is usually faster than the bubble sort. And it's particularly good to use with a list that is partially sorted, because in that case there are only a small number of values that need to be passed backwards up the list. It doesn't use up any memory space, but it is slower than the other two sorts that we're going to look at next, the merge sort or the quicksort. The merge sort uses two functions. One is a merge function and the other is a sort function that splits the list and then uses the merge function to merge the little lists back together again. You would recognize the merge sort because it uses two subroutines. If you see two subroutines, it would be either the merge sort or the quicksort. The key fact about merge sort is it finds the midpoint. So if you've got a program that finds the midpoint, it's either merge sort or binary search. And obviously if we're sorting the list, it will be merge sort. And we usually write it using recursion, though there are other variations. The merge sort has an unusual number of operations, which is identified as n multiplied by the log of n. The other key thing about the merge sort is because it always splits the list down into groups of one and then always merges them back in twos. It always takes the same amount of time. With a list of n items, you can repeat the merge sort on different lists, but it will always be n times log n operations. So it's a very reliable, fast sort. So what's not to like? It's the fastest sort that we've learned, and it's very reliable, but, and there's always a drawback to any algorithm, and the drawback of the merge sort is it does use extra space in RAM. So you'd have to consider whether that was important in any particular case. And finally, the sort of Maverick sort is quicksort. That uses two routines, but instead of splitting the list into two equal halves, it chooses a random value as the pivot, and it moves the values backwards and forwards so that they're either side of the pivot. Because it does this by swapping values in place, it doesn't need extra RAM. So how would we recognize the quicksort? Like merge sort, it will use two routines, but the second routine is a partition routine. It partitions the list into two random around a random pivot value, and it doesn't make a new list. It doesn't use extra space in RAM. The speed is highly variable because of this random element. It's usually pretty fast. It can be as fast as the merge sort in many cases, but in its worst case, it can take n times n operations. And That's as slow as the bubble sort. That might be quite rare, but it can be a slow sort if you're not lucky with your values. So to sum up what to say about the quicksort, it is generally a fast sort algorithm, but it is not as reliable as merge sort. On the positive side, it uses less memory. So I just summed up the situation with the sorts. Bubble sort sorts in place and only has a single subroutine. Insertion sort sorts in place and only uses a single subroutine. Merge sort does not sort in place. It creates multiple copies of the list in memory, and it uses two subroutines. The second subroutine merges two lists to create a bigger list. Quicksort sorts in place, so it doesn't use extra memory. It has two subroutines, and the second one partitions the list and returns the pivot value, which is then excluded from any future sorts. And if we compare their advantages and disadvantages, the bubble sort is simple, but that's about all it's got going for it. It's very slow with a speed of n times n. The insertion sort is better. It can be slow, but it works well with an almost sorted list. In the worst case, it can be n times n operations, but it's generally faster than the bubble sort. The merge sort is nice and reliable and fast. It needs extra space in memory, but the speed is n multiplied by log n, which is the fastest of the sorts that we've learned. Quicksort is also fast and doesn't use RAM, but it does have this unreliable random factor, so its speed can vary from n times log n to n times n and anywhere in between. So to recap, those are the key facts I think you should know about the bubble sort, the insertion sort, the merge sort and the quicksort, and I recommend you use that as a checklist for your own revision. And if you're my student, there'll be a mini mock on all the sorts, so immediately you need to revise that. But everybody who's thinking of doing the A-level, those are some key facts that you should have at your fingertips about the 4 sort algorithms. This is my last lesson about the sort algorithms, and now I'm going to move on to talking about the key data structures such as the stack and queue. So I'll see you then. Bye for now.